Okay, so we are on to Newton's third and final law. We dealt with Newton's first law, which was the law of inertia. Just to recap, the law of inertia, and remember, inertia refers to objects being lazy and that they want to just continue doing what they're already doing. So if they're sitting at rest, they want to stay at rest. If they're set in motion, then they want to continue in motion unless an external force is acting on them. Then we moved on to Newton's second law, and that dealt with the changing factors of force, mass, and acceleration. And when we're talking about a moving object, if we change any one of those three components, force, mass, or acceleration, the other ones are affected directly or indirectly. So Newton's third law, the simple way of referring to Newton's third law, or another way of saying it, is often called the action-reaction law. And this is just a really simple sort of concept to think about. Newton's third law acts in so many different everyday life situations. And I'm going to use this rocket as an example to start. So remember, there's always, when we're talking about Newton's third law, there's always an action and a reaction to it. So if we ask ourselves what forces are acting on this rocket, okay, what propels this rocket forward, we're going to come up with two things. There's an action and there's a reaction. So the first thing we want to look at, what's the action force that's happening? What's the thing that's going to initiate this motion? If it weren't there, it wouldn't happen in the first place. So that becomes our action force. So we have the combustion and expanding gases out. So the combustion of fuels and expanding gases out the end of the rocket. Is that what propels it forward? That's only half of what propels it forward. So when we talk about Newton's third law, there's always two components, an action, and in order for the actual motion or object to move, we need this reaction force. So the action is the combustion of the fuels that then shoot out with a force out the back of the rocket, and then you end up with all of these expanding gases. The reaction, which actually causes the motion itself, is those expanding gases pushing back on the rocket with an equal and opposite force. So the expanding gases pushing back on the rocket with an equal and opposite force. And this combination of the action and reaction is what causes the motion itself. Okay, so if we were to break down Newton's law in scientific terms, Newton's third law of motion says that for every action force, so this applies to most situations, if we have a force that's being applied, there is a simultaneous reaction force. So I'm going to underline these. Pens. So for every action force, there's a simultaneous reaction force that is equal in magnitude but opposite in direction. So the one that you might be able to relate to a little bit more, because we've dealt with it, but just not in this detail, is, remember we talked about the free body diagrams for an object that's just stationary, let's say. So let's just say we have example. Oops. If we had anything that is any object, so let's just say a book, and it's still using my arrows. Hold on one sec. I'm going to pause. Okay, I think we got it. If we use the example of a book resting on a table. Now, this is going to walk you through a few of the concepts we've learned so far. Book is represented by a dot. Gravity, because we're near the earth, it's always going to be present. So we have a gravity pulling the book down onto the surface of this desk. But remember I said if gravity were pulling something down and nothing were balancing it, it should continue to fall through that desk. And because it doesn't fall through that desk, we know that there's some sort of equal and opposite force that stops it from being pulled down further as a result of the gravity. And remember, for anything that's resting on a surface, that equal and opposite force we call the normal force. And here's a perfect example of Newton's third law. So anytime you have anything that's resting on the surface of anything, like you even sitting on your chair right now, the reason you don't fall through that chair is because you're balanced by this force called the normal force, and it fits under the umbrella of Newton's third law. So if you have some sort of action force in one direction with an equal and opposite reaction force in the opposite direction, that's an example of Newton's third law. Okay, and I'm going to post a couple of videos just to kind of give you some everyday examples. Another one I can think of, I'll post actually. Okay, so on the next page here, I'm just going to throw in a few more examples to maybe help you get the idea with some everyday life examples. This isn't the best photo, but if you picture blowing up a balloon, and this is what this is, a bunch of balloons. If you don't tie off the end of the balloon and you let that balloon go, imagine what happens to it. It flies all over the place uncontrollably. And so if we relate this to Newton's third law, what's happening here, gas is being forced out of the balloon because there's built up pressure. So the gases are coming out. That's the action force. And surrounding it, if it's resting on a table, that air coming out might be forced against a table or a wall or your hand. Or if it's just in the air and it's flying around, it might be forced against the air molecules. So the reaction which propels those balloons forward is an equal and opposite force back on the balloon from air or another surface of something. So the balloon's pushing out with force, that's your action, the air and the gases, and those gases are pushing against something that cause that equal force back on the balloon to propel it forward. Okay, another example, I just found this picture, I've never seen anything like it before, but I was actually going to just think of a simple hose, and then I saw this one, and it also works. If you ever had a hose that's got water full force coming out of it, and you've let it go, and that hose just flies all around the place, that's because the force of the water, so the force of the water coming out is your action. But as that water is being forced out of the nozzle of the hose, it's putting an equal and opposite force back on the hose. And that reaction force back on the hose from the water propelling out of it so fast is what's pushing back on the hose and making it fly all over the place uncontrollably, much like the balloon. And then this is the same thing. This is a water jet propelled device that's lifting this person off the water. So the water shooting out of this hose that's on either side of his backpack, and the force that's coming out of there is putting, so that we've got an action force, and that same water that's coming out of there is pushing back on where it's coming out, but because it's attached to this person, that force is actually applied to the person. So that reaction force, equal and opposite, is what's propelling this person upward. Okay, so there's some examples of your action and reaction force, and that's really pretty much it for Newton's third law. I'm going to post some videos to give you some more ideas, and then what you're going to do for your final assignment for this unit before we start working towards getting ready for your unit test is an assignment where you search online for some pictures that represent each of Newton's law, and you put a little summary beside each of them. So that's going to be after probably Tuesday, after you get through this note on Wednesday. And remember, we have a unit test coming up, which I'm going to post a video that summarizes the main concepts we've learned. I'm going to I'm going to type out a formula sheet for you guys that you can print out and use during your test. Okay, so just one last reminder that you really, really, really need to get caught up on any of the calculation type assignments that need to be handed in for this unit, because those are the types of calculations and questions you're going to see on your unit test. All right.